So today we are talking about how we can create pattern rules from models. So I'm starting with this question here. Write a pattern rule to describe the number of toothpicks in each figure of this toothpick fence. So when you start with this picture, I'm going to show you two different ways that you can solve this particular question. To take this model of a pattern or picture pattern using some kind of concrete material, and how you can take that and actually turn it into an algebraic expression using numbers. Okay, so let's start that. So the first thing that I'm going to do is I'm going to look at the picture here that I have, and I'm going to decide what part of this pattern is the same and stays the same every single term. So for figure 1, figure 2, and figure 3, what part of the pattern is actually staying the same? And I see that in particular, the part of the pattern that's staying the same is this toothpick right here. It's the same in this one, and it's the same in this one. And then I have this other part of my pattern, these 4 and 1 here, and then these 8 and 2 here, and these ones here. So the way that I would differentiate those, the red is staying the same, so the red is the constant, and the blue is my variable. Just like we've talked about, constant means it stays the same, variable means it changes throughout the pattern. Now, when I look at the variable part of these figures, the blue part that I have circled, I see that the number of fence sections actually equals the number of the corresponding figure. So for figure 1, I have 1 new section. For figure 2, I have 2 new sections. For figure 3, I have 1, 2, 3 new sections. So that actually works really well for me, that I've got figure 1 corresponds to that number of fence sections, figure 2 corresponds to that number of fence sections, and figure 3 corresponds to that number of fence sections. So now, in order to answer this question with words, I would say that I would have to identify my variable, and then I would have to describe my pattern rule, because that's what it's asking for. It says write the pattern rule to describe the number of toothpicks in each figure of this toothpick fence. So we normally represent our variable when we're talking about patterns with the letter N. We've talked about this a little bit before. I'm actually going to do that in a different color so that it doesn't confuse you. So I have written my pattern rule now. I said that my variable is N and it represents the number of sections of toothpick fence. And my pattern rule is 5n plus 1. And we've talked a little bit about this before, about the zero value term and the common difference fitting into that equation. And I will come back to that later. But right now, I just want you to look at this model and the blue and the red, the constant and the variable. So I'm showing you this expression here, this algebraic expression. And you can see here that the 5 is coming from my variable, the number of fence pieces added each time, and my 1 is coming from the constant, the fence post that stays the same each time. Okay, so when you write your expression, that's another way you can think about it, is that you're going to do the variable multiplied by your term number plus whatever your constant is. And then, like in any problem in math, we want to check our work. So the way we can do that with this pattern rule, we're going to check our pattern rule to see that it's right. So our pattern rule is 5n plus 1. So for figure 1, that looks like this. 5 times 1 plus 1. We know 5 times 1 is 5, plus 1 is 6. How many fence posts do we have here? 1, 2, 3, 4, 5, 6. So 1 is right. Let's do one more. We know figure 2 is 5 times our variable number, which is figure 2, plus 1 equals 5 times 2 is 10, plus 1 is 11. Do we have 11 here? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 toothpicks. So I would say that we've checked our work there and that pattern rule absolutely is a way that we can represent that model. So here's another way that you can solve this problem. I'm going to start by circling the first post again because that's what each figure begins with. Next, I'm going to circle the second part of the figures, which is the part that changes. And there's two parts that actually are changing. One is the rails that go horizontally, and one is the posts that go vertically. So I'm going to actually circle those separately this time rather than together like I did the last time. So what I've done right now is I've actually shown that each new figure adds 4 rails and 1 post. So here I've added that I'm going to use the variable s this time to represent the number of sections after the first fence post. And then this is how I've written my pattern rule this time. So s is the figure number, and 4 rails plus 1 post is what's being added each time. That's getting multiplied by the figure number. And then we're adding 1 because the constant each time is 1. So I can use this pattern rule to describe the relationship between the figure number and the number of toothpicks. And then we test it, just like we always do. So for the first one, if we turn, so if s equals, or s times 4 plus 1 gives us our value of our terms, then we'll try for figure 1. 1 times 4 plus 1, which is 1 times 5 is 5 plus 1 is 6, which is the number that we have in our first section of fence toothpicks. Then we can do figure 2 is 2 times 4 plus 1 equals 11, because this is 5 times 2 plus 1 is 11, which is correct again. So this is just another way that we can show our thinking and create a pattern rule from a model, from a visual model. I hope that this helps.